Okay, so today, section 7.5, okay, it's on glide reflections and compositions. Okay, a glide is another word for a translation, like something gliding along. Okay, so a glide reflection is two transformations together. You glide something, and then you reflect it. Okay. Okay, so in a glide reflection, as I just said, first you do a translation, or glide something, and then you do a reflection over a line. But in a glide reflection, the line has to be parallel to the direction you translated. So if you translated something, for example, I think I have a picture. Like, let's say you translated point P to the right and up a little bit. Well, the line that you reflect over has to go to the right and up a little bit. Okay, so the direction of translation has to be parallel to the line you reflect over. Otherwise, it's not a glide reflection. Okay, so if I had something and I translated it straight down, my line of reflection would go straight up and down. Okay, the line of reflection goes in the same direction as the translation. Okay. Generally, the colors that they're going to use are blue, red, green. Blue is the original. Red is the first transformation. Green is the second. So blue, red, green. Okay, so I translated P to P prime, Q to Q prime, and then I reflected. Okay, any question on that? Okay, the P, you know what, I'm just looking at the blue and the red one. That one looks fine. But how about when I reflect it? Look at the points on the red segment and on the green segment. Yeah, if I reflected it, what point would that top one be?
Q.
Q prime, or double prime. Yeah, that would be Q. Okay, because when you reflect it, Q was the one that was closer to the line, so Q still has to be closer to the line. P was farther away, so P should be farther away. Okay, so now that's correct. Any question on that? All right. So in a glide reflection, do you think the order you do it in matters? If you glide and then reflect, or reflect and then glide? Nope. It doesn't make a difference. And the reason it doesn't make a difference is because the line that you're reflecting over is parallel to the direction of translation. That's why if you switch the order in a glide reflection, you'll still get the same thing. Okay? Just imagine this one. Take PQ and then translate it, or actually, you know what? Reflect it first. It would end up down here. And then translate it. It would end up right there. It's exactly the same as taking it, translating, and then reflecting. Okay? So you get same thing both ways. Okay, it's kind of like if I said to you, you know, if you were on a map, and I said, I want you to go up 3 blocks and right 4. Well, whether you go up and then right, or right and then up, you get to the same point. Wouldn't matter which order you did it in. Okay, but when you do these transformations, it's kind of think of it as like PEMDAS. Okay, sometimes the order it is important. For example, with addition, it doesn't matter. If I said to do 5 plus 2 or 2 plus 5, you get the same answer. But if I said to do that with subtraction, Is 5 minus 2 and 2 minus 5 same thing? No. You get different answers. So sometimes the order you do it in matters. Sometimes it doesn't. All right, so let's try to do a sketch. Okay, and it says use the information below to sketch the image of the triangle with those coordinates after we do a glide reflection. Okay, so there's my glide, my translation. I wrote it, I didn't use vector form. And then we're going to reflect over the x-axis. So this part requires that you know what the x-axis is, what the y-axis is, basically how you draw lines. Okay? I'm not going to draw the x-axis for you. You have to know where that is and reflect over it. Okay, so what I've done is I put our triangle with its vertices. Okay, so A is -1, -3. B is -4, -1. C is -6, -4. Okay, first thing I'm going to do is translate it using what they've given me. Okay, who can describe what is this translation doing? It's taking the triangle and doing what? Yeah.
So we're going to the right 10 units.
Right, it's going to move it to the right 10 units. I'll do this in red since this is our first transformation, just to kind of make it match up with the book. And it just says to make a sketch. It doesn't actually say I need to write down what A prime, B prime, and C prime are. I just need to draw it. Okay, so take every point and move it right 10. Okay, so there's A prime. And now what I could do is I could just keep counting 10 over from every point, or from the A, I know that I go up 2, left 3 to get to B. So I can use A as my point of reference now to figure out everything else. That's probably easier. Then I don't have to count as many times. So I'm just going to go up 2, left 3. Up 2, left 3. The only danger with doing it that way is if you got A wrong, you just got B wrong. It's B prime. And then from A, we're going to go down 1 and then left 1, 2, 3, 4, 5. So down 1, left 5. Okay, does that look like a translation, right? 10 units? Yep, looks good. And now the next part is to reflect in, means over. Reflected in or reflected over the x-axis. Okay, which axis is my x? Oh, yeah, here?
Horizontal.
The horizontal. So I'm reflecting it over the line, basically y equals 0. That's the equation of the x-axis. Let's start with point B. How would I reflect point B over the x-axis? What would I do? Well, you know what? I said I was going to do that in red. Let's just change it to red. How will I reflect point B over the x-axis? Ariel? Yep, so I'm going to pick point B. B prime. Sorry.
You would just reflect it.
Okay, how do I do it though? How do I know? Do I like put B over here?
You'd keep the same x.
Okay, yeah, keep the same x.
But the y, it would be positive because it's on the negative side right now.
Yeah. So to reflect over the x-axis, keep the x value the same, just make the y the opposite. Right? So there's it's B prime. A is, or you can count, A is 3 units below, make it 3 units above. There's A prime. C, 1, 2, 3, 4 units below, 4 units above. So if we redo this, connect it, there's my reflection. And those are double primes. Okay, the prime basically just indicates how many times you did the transformation. Okay, any questions on that? Okay, so that's a glide reflection. Glided 10 units right, and then we reflected. So a glide reflection is a specific example of taking two transformations and putting them together. Okay, when you combine two transformations to get a new image, that's called composition. Okay, so a composition is when you take two or more transformations and put them together. So in a computer, remember I showed you guys yesterday or maybe a couple days ago, I showed you that matrix for rotating something? Well, you could build a matrix that at the same time, say, does a rotation, a reflection, and a translation. You could build all three transformations into one matrix. So it's all done in one step at one time by the computer. So the computer never actually does it one step at a time. It can just go right from the original to the final. Okay, and then theorem 7.6, that's the composition theorem. Basically, it says if you take two transformations that are isometries and you compose them, it's still an isometry. So in other words, if you do something that doesn't change the size, doesn't change the length of the sides, keeps the area the same, keeps the perimeter the same, all those criteria that we described in isometry. If you do it once, and then you do it again, you still haven't changed the size of the sides, length of the sides. Okay, so a glide reflection is an isometry. Okay? A glide is a translation, that's an isometry. A reflection, that's an isometry. Put the two together, you still have an isometry. Okay, so we already said that for a glide reflection, the order that you do it in doesn't matter. You can glide and reflect, or reflect and then glide. But in general, the order usually matters. If it doesn't matter, it's because there's something special happening. Like in a glide reflection, we're reflecting over a line parallel to the direction of translation. Okay, when I teach in trig about translating, like sine or cosine, generally, if you're doing a transformation, like a translation that affects x, and then a separate translation that affects y, you can do them in any order. Shifting, as I said, up and then right, or right and then up. That also won't matter. Okay, but certain combinations, when you put them together, changes the result that you can get. So we're going to look at an example with a rotation in it. Okay. And as I said before, that's kind of the normal convention that they'll do transformations in. Blue is the original, then red, then green. All right, so what we're going to do to make it simple, we're just going to sketch a segment. Okay? It's the segment PQ. And I want to do these two things to it. I want to rotate it 90 degrees counterclockwise. Okay, so hopefully you guys remember that trick I gave you with what you do with the two letters and then do something else to the first one. And then we're going to do a reflection over the y-axis. Okay, so there's PQ. That's my original. Okay, let's do it in the order that I have listed first. Let's rotate it and then reflect it. Everybody have what's on the left? Okay. All right, so what is the trick to take a point and rotate it 90 degrees counterclockwise? What do you do with the two numbers? Two steps. First step. Do you remember yet?
Don't you flip the numbers?
Okay, switch the numbers. That's step one. And who can tell me the second step?
Make first negative.
Make the first, after you switch them, make the first one negative. All right, so let's, off to the side, let's do Q. Okay, that's 3, negative 4. That's going to become Q prime. If I switch them, I'm going to get negative 4, 3, and then make the first one negative. So instead of negative 4, 3, it becomes positive 4, 3. Any question on that? Okay, so let's sketch it. 4, right, 4, up 3. Okay, there's Q prime. Okay, let's do the same thing for P. I started with Q because P is a little more confusing. The numbers are the same, so when you switch them, you don't notice, and then you make it negative. It's kind of hard to tell what happened. Okay, so P is 2, negative 2. And we'll switch them and make the first one negative. Okay, so what's P prime going to be? Yeah,
2, 2.
good. 2, 2. Up 2, right 2. Okay, and if we've done this right, it should look like a 90-degree counterclockwise rotation about the origin. Okay, now I'm going to reflect it over the y-axis. Okay, which one is the y? Melissa?
The y-axis is the vertical.
The which one? Vertical, yeah. It's x, that's y. So when you reflect over the y-axis, which part of the coordinate stays the same? The x part or the y part? Yeah.
The y part?
Yeah, the y part. These points aren't going to change height. They're going to change where they are horizontally. That's the x. So P double prime is going to be right there. Q double prime is going to be right there. Okay, so that's what you get if you rotate and then reflect. Any question on that? Okay, let's switch it. Let's do the same example, except now we're going to reflect and then rotate. Okay, so step 1, we'll reflect. Step 2, we'll do the rotation. Okay, and I'll try to keep both up so we can compare. Okay, so first thing I'll do is reflect. So that's going to be P. Whoops, that's P prime. And then Q was 3 units to the right of that y-axis, so go 3 units to the left. Okay, there's Q prime. Any question on the reflection? Okay, now I'm going to rotate. Since we're going to deal with the numbers, it helps to write them down, so let me make it a little bigger. Okay, so P prime is negative 2, negative 2. Q prime is negative 3, negative 4. Okay, who can remind me again, what's the trick to rotate 90 degrees counterclockwise? What do we do? Selena? Switch the numbers and then make the first one negative. So when we switch negative 2, we get negative 2, negative 2, and make the first one negative, which in this case it already is, so it becomes positive. Okay, let's do Q double prime. Switch them. get -4, -3. And then when you make the first one negative, instead of -4, it becomes +4. Okay. So let's sketch P double prime, Q double prime. So let's see, P double prime is right 2, down 2. Right 2, down 2. And Q double prime is right 4, down 3. Right 4, down 3. It's kind of ended up back where it started a little bit, but not exactly, okay, because it rotated. So what do you notice when we change the order? Did we get the same answer? Nope. Okay, so the order that you do it in makes a difference. Okay, that's what I was just showing them. Okay, so what do you notice? We could write down different answer. Okay, this one is a transformation I've already done. I just want you to describe what's happening. Okay, I've tried to make it easy to figure out in two ways which one is the original, the first, and the second transformation, using the same colors we've been using, and the primes. All right, so for our first transformation, what two figures are you comparing? Which one can we kind of forget about for now? That'll come in later. Yep. Right, A, B, C, D, and A prime, B prime, C prime, D prime. So forget about the green one for now. Just look at the blue and the red. What kind of transformation would you do to change the blue into the red? Okay, it is a reflection. And now we've got to be a little bit more specific about a reflection where. Because there's all kinds of ways you can reflect. Okay, so let's start writing down what we've got. Step 1. Reflect over. Well, we can name that. From Algebra 1, we can give this line, there's an equation for it. How does the equation, well, first of all, is it a vertical line or horizontal? It's a vertical. You're reflecting over a vertical line. The equation for a vertical line always starts with what letter? What letter?
X.
X. Y equals a number. That's a horizontal line. X equals a number. That's a vertical line. The number is where the vertical line is. So where's the vertical line here? 2. That's the equation of that line. X equals 2. So reflect over the line. X equals 2. Okay, that's the first step. Okay, second step. Now we're comparing the red to the green. Okay, what kind of transformation would change the red shape to the green shape? Translation, reflection, or rotation? Oh, Sarah? Yeah, that's a rotation. Okay, and if I have you look at it, I'm not going to do a tricky rotation. I'm going to try to make it look very obvious what it is. How much does the angle of rotation look like? Yeah, so that is 90 degrees. But just like with a reflection, we've got to be more specific. Rotate 90 degrees, which way? Clockwise. Okay, you could confirm that it's a 90-degree clockwise rotation by using the formula that I gave you. I think we did it as counterclockwise, which would be 270 counterclockwise and look at the formula. Okay? Use the formula to change D into D prime. If the formula for a 270-degree counterclockwise rotation works, then you just proved what we wrote. Okay? But again, I'm not going to give you something that's an arbitrary angle. It'll either be 90, 180, or 270. Okay, something you can work with. Okay, any question on that? Okay, so that's composition of transformations, just putting two or more together. We didn't do 3, but you could do 3 if you wanted, 4, 5, however many you need. Okay, so for tonight on 433, okay, the homework is 9 to 17 odd, 23 to 29 odd, 33. And for MCAS, let's do on the multiple choice, I think we have 9, 10, and 11. Those are the last 3. And do the open response. Okay, and we'll try to go over that tomorrow.